If we want to find out about the number of degrees inside a triangle, so what the angles in a triangle add up to, we can use some clever little tricks. I've got 3 different shaped triangles here made out of paper. And what I can show you is that if I cut off, and I'm going to rip them rather than use scissors, if I cut off all 3 of these angles, can you see that I've torn the corners off at the end of my triangle? If I put those 3 angles together, what I hope you'll see is that we end up with a straight line. Can you see that? There we go, those 3 angles made a straight line. And I'm doing it 3 times to show you that it doesn't matter what type of triangle you've got. You can see that's a completely different shape to the last one. But again, if we tear off those 3 corners and put them back together again, and I promise there's no sleight of hand involved here, this is all real, not magic, you can see that the 3 corners add up to make a straight line. It's clever, isn't it? And just once more. Couldn't tear it then. It's a bit embarrassing. Put the 3 corners together and you can see we have a straight line again. So it doesn't matter what type of triangle you've got. If you have 3 corners on your triangle, so you will, because it's a triangle, or it wouldn't have 3 corners, triangle, 3 corners, 3 angles. Those 3, that one and that one and that one, add up to 180. So angles in a triangle add to 180 degrees. And that's really helpful because we can use that information to help us with other shapes. So for example, a random quadrilateral. And I'm deliberately making it irregular, not just a square or just a rectangle. So a weird and wonderful quadrilateral. But it doesn't matter what shape my quadrilateral is, how wonky it is, whether it's a regular shape or an irregular shape, each time I can still make it into 2 triangles. Like that, can't I? And if I didn't want to draw the line there, I could draw it the other way. So long as I'm going from one corner to another corner, I end up with 2 triangles. And if I know that the angles in a triangle add up to 180, that means that those 3 angles give me 180 degrees. And these 3 angles give me 180 degrees. And that way I can tell that I've got 360 degrees altogether, because 180 plus 180 is 360. And this fact works for any polygon, and a polygon is a straight-sided shape. So it won't be any good in a semicircle or in a circle, but in a straight-sided shape it will work. So for example, if I were to draw myself a hexagon, it's relatively regular but probably not perfect. If I pick a point and then draw from that point to all the other points that I could make a triangle from, so obviously I couldn't make a triangle by drawing along there because that's a side, but I can by drawing it to here and by joining to here and to here. I've got 180 degrees in that triangle. I've got 180 degrees in that triangle, one more here and a final one there. So I have 180 times 4, 4 8s are 32, 4 1s are 4 plus the 3, there are 720 degrees in all of the internal angles of a hexagon. And like I say, that would work for a pentagon or for a septagon or a heptagon, we call it in the UK, or any of those other things, any other straight-sided polygon. Okay?